Okay, now that we understand the meaning of a rational exponent, let's apply this knowledge and actually evaluate an expression that contains the rational exponent. So let's go back to that example, 8 to the 2/3. We have the base 8 and our exponent's 2/3. And we know that exponent does not make sense because for an exponent to make sense, it must be a positive whole number. So what we have to do is, because our exponent's a rational number, a fraction, we must rewrite this expression so that it contains a root and an exponent. So we put inside as the radicand the base 8. We give it the exponent 2 because the numerator is always still the exponent, and we say the denominator is the root. So we rewrite 8 to the 2/3 as the cube root of 8 squared. Now all we have to do is evaluate this expression following, please excuse my dear Aunt Sally, PEMDAS. And we know P means please do what's inside the symbol first. And we have an expression inside the symbol. We have the cube root of 8 squared. So inside the symbol we have 8 squared. So we'll do that first. What is 8 squared? Well, we understand that. That's 8 times 8, which is 64. So now our expression is the cube root of 64. So once we perform the operation inside the grouping symbol, now we can actually do the operation of this grouping symbol. Now let's do the cube root of 64. Well, to do a cube root, your number must be off the perfect cube list, which means you have to have that memorized. Let's go through the perfect cubes. 1, 8, 27, 64. There it is. What number do you multiply 3 times to give you 64? That would be 4. So now we know the cube root of 8 squared would be 4. What I want you to understand is when you're evaluating a rational exponent, when you rewrite this statement, you're really doing 2 operations. You're doing a root and you're doing an exponent. Now, what's important to understand is if we follow order of operations, we've talked about sometimes operations, it doesn't matter what order you do them in. Remember, A and S, add and subtract, are equal. So it doesn't matter if you add first or subtract first, we'll get the same value. We've discussed this. Multiply and divide, mom and dad are equal. So it doesn't matter if you multiply first or divide first, you'll get the same answer. Well, E, exponent, has an equal operation, which is P, but it's not parentheses, it's the root. So if P and E, if a root and an exponent are equal, then it shouldn't matter which one you do first. So let me show you another way to evaluate the cube root of 8 squared. Instead of doing the inside first, the exponent first, I'm going to now do the root first. So if I read my expression, I say the cube root of 8. Well, I can do that because I know 8 is a perfect cube. And I know the cube root of 8 is 2. But now that 2 gets the exponent, which is square. And what is 2 squared? 4. So if you look, ladies and gentlemen, I got the same result. Because exponents and roots are equal, it doesn't matter which operation you perform first. So in general, I will tell you in algebra, it is easier to perform the operations in order as you read them. So most of the times it is quicker for the calculation to do the root first and then do the exponent. Okay, let's go to the whiteboard and try a couple of expressions.